All right, hi everyone. So the goal of today is again looking at a system of equations. What we did before again was we graphed the two lines. We said, hey, these two lines share only one common point in this problem. The blue and the red line meet at 3, comma, -4. Now the equations could start off a little funny, right? And we ended up changing those to y equals 2. And today we're going to work with something like this. Instead of graphing though, I'm going to show you how to solve these lines, the solution for these lines, this system, through an algebraic process. And it's nothing really new that we've learned already, but we're going to apply it a little differently. Okay? But we will be using our algebra. We're going to be solving for x, solving for y. So everything that we worked on in first semester, we're going to do that right now. So here we go. Here's our first example. If I give you the equation, so today we're going to solve, whoops, let's change the ink. So just start taking notes. Solve a system of equations by substitution. Now, substitution is the method. We have a couple of methods that we're going to learn. We've already learned it by graphing. We looked at where these lines intersect on a graph. That's solving by graphing. Today we're going to do substitution, and then we're going to do combination, linear combination, or sometimes they call it elimination, depending which book you use, on the next time I see you guys. So today we're doing a substitution. All right. So let me give you an equation, and we say y is equal to, let's say, 3x squared plus 4. Okay. Oh, sorry, not 3x squared. No squared, please. No squared. I'm sorry. And then I'm going to say y is equal to negative x plus 8. Okay, negative x plus 8. Right. So we could graph these lines out and figure out where they intersect. But I want to teach you guys a new method today. And this has nothing to do with graphing. We're going to use graphing to check a little bit later. But we're going to use the algebra skills that we learned already. And this idea of substitution. Now, you guys have heard the word substitution in many ways, like in sports, when someone gets substituted, a player gets substituted off the court. Maybe a teacher you had a substitute before, where a teacher was replaced with a equivalent person, right, to manage the class. And the idea of substitutions here is that I get to replace one thing for another, but these have to be, I would say, equal in weight, right? You can't trade a high school teacher with an elementary school teacher, right? You can't do that. You don't want to trade a basketball player who's doing really well with a bad player. You want to trade someone who can carry his weight. So our substitutions here are going to be of equal weight. They have to be a good substitution, right? We can't trade the number 5 for 4. That wouldn't be a good trade. We would trade a 5 for 5. But in this case, I want to say this. Both the equation, line 1, we'll call this line 1, and line 2, they are going to share the same common x and y. What I mean is, they're both going to have the same x and y that would be equal to each other. Right? Because if they meet at the same point, they share the same x's and y's. Now, here is the big trick. If I tell you y is equal to 3x plus 4, y is equal to 3x plus 4, y is equal to 3x plus 4, shouldn't this y here also equal to 3x plus 4? What I mean is, if they were exactly the same point, right? The idea is that they have to share the same point. Well, this y should be equal to this y. And this is what we're going to say. Isn't y equal to y for both these problems? And if they are equal, this is what we're going to do. We're going to say, hey, this y is 3x plus 4 is equal to this y, which is negative x plus 8. So what we did is we took two equations and two variables x and y, and look what we did. We, by their powers combined, you guys ever see a show called Captain Planet? They combine their 5 powers, their 5 rings, and they're going to combine to one equation and one variable. and in this case, just x. Please notice that we went from two variables here, x and y, and we only have now one combined equation with only one variable left. And this takes us back into our first month of doing algebra, where we only had to worry about one variable. Now let me go ahead and show you how we're going to solve this. Let's go ahead and combine our x's. I see I have positive 3x and a negative x. I'm going to always move x's to the side with more. So which side has more, the 3x or the negative x? Hopefully you're saying the 3x. So I'm going to add x to both sides because I want to move over this negative x over. Opposite operations. That's 4x plus 4 is equal to 8. Now let's go ahead and subtract 4 to both sides. Oops. Subtract 4 to both sides. 4x is equal to 4. Then I'm going to opposite multiply by 4 is divide by 4. X is equal to 1. So we went ahead and we solved for that one variable, and I'm telling you this now, x is going to be the same for both these equations. Remember, they're going to meet someplace, and that point I have concluded is going to be x is 1. Now, great, x is 1. But how many variables do we start off the problem with? Let's take a look at the top again. We started off with x and a y. So once you find one variable, we plug it back in to find the next variable, the y variable. In this case, if I find x, now I'm going to find y. In another case, if I find y, then I can go back and find x. So you get to choose which equation you want to use. So, but in this case, this first time that we're going to do, I'm going to do actually solve them for both. We said x equals to 1, so it's going to be 3 times 1 plus 4. And let's see what our y value is going to be here. Y is equal to 3 plus 4 is 7. We have y is equal to 7. Now, what if I use the second equation, line 2? If I did line 2, y is equal to negative 1 plus 8, and negative 1 plus 8 becomes y is equal to 7. And please notice that these y values were exactly the same. So it doesn't matter which equation you want to go back and plug it back into. They're both going to give you the same answer. Now the full solution to this is x and y is 1 comma 7. Now that is the point where they meet. Now, is this easier than graphing lines? I would say yes, but there's some circumstances here. If you're graphing lines on Desmos or on IXL, that was actually pretty easy. The computer does all your work. It draws your x and y axis, it gives your tick marks all done, and it's super accurate. You can nicely see where these lines meet. And they even tell you by clicking it. But if you had to draw this by yourself on a piece of paper, how accurate are your drawings really? And oftentimes, they're not the best, honestly, right? So it's sometimes hard to see where they meet, even though you did all the graphing work. Algebra, though, there is no parallax. It's not like it kind of looks like 1 and doesn't look like 1. It's 1. X is 1. And when we plug x into the equation again, we end up with 7. Now I'm going to go ahead and graph these lines here. Just to prove this to you, let me go ahead and show you guys this. Let's go ahead and here we go. I'm going to go ahead and graph this. Oops, wrong one. To prove that these lines do meet at the right place, y is equal to 3x plus 4. That's one equation. And then y is equal to, y is equal to negative x plus 8. Now we drew those two lines. Let's go take a look. Where do they meet? They meet at the nice 1, 7, which is what we came up with. So this method of solving a system of equation algebraically is called substitution, because I'm substituting variables into the other equation so that instead of having two equations, two variables, we have one equation and one variable. Now let's see another problem. Let's look at an easier, more basic version of this. Okay, so now that we have the general idea. So we did it algebraically, we got the right answer. We graphed it, we got the right answer. Now let me go and give you an easier one. If I said 4x minus 4y equals to 12 and y is equal to negative 5. I have two equations, right? And in this case, I have two variables I don't know. I don't know the x or the y. I don't know her first name or her last name. How am I supposed to ask her out on a date? I don't know anything about her. Okay, so we're going to use substitution here. And I'm going to say solve here. So solve for both variables x and y. Now, here is one of the cool things here. They already gave us one of the variables. Which variable did they give us? Well, the top says 4x minus 4y, so we don't know what x and y are. But my second equation, y is equal to negative 5. Oh, I know what y is. Y is negative 5. So let's go ahead and substitute it in. Hey there, we know what y is. 4x minus 4y. We said y is now going to be substituted with negative 5. Right? And we've called this plugging in before. Plug in your variables. But the fancy word is substitute, right? We're substituting the y value, y variable, for a value of negative 5. Let's go ahead and multiply that out. 4x minus negative becomes a positive 20 equals to 12 minus 12 to both sides. 4x is equal to, oh, that's 0. Ooh, wait, that's not right, is it? Oh, that was 20. Whoops. Sorry. That should have been 20. I don't know, I was going the wrong way. I need to clean up my mess, not make it more messy. Okay, we're moving the numbers over. Sorry about that. Negative 8. And then divide both sides by 4. X is equal to negative 2. Now, this seems a little suspect. Okay, was it that easy? We have x and y. Do I need to substitute it back in to find the other variable? Well, ask yourself this question. What are we solving for? We're solving for the variables x and y. Well, they gave us y, so they did half the work for us already. Great. So we found the x. The solution is negative 2, comma, negative 5. Let's see if this is true. Let's double check. If I plug in 4 times negative 2, because that's my x value, minus 4 times negative 5, that's my y value, does this give us positive 12? This is negative 8 plus 20 is 12. Yes, that is true. 12 is equal to 12. We have found the solution that worked. Okay. Now, if I graph this, would this have given me the same answer? So let me go ahead and take out my little graph here, Desmos. And our first equation was 4x minus 4y equals to 12. My second equation here was y is equal to negative 5. All right, so let's go ahead and look for our solution here. No, sometimes it doesn't graph that one. I don't know why. Oh, here's negative 5. All right, so you can see y is negative 5. Oh, y is negative 5. And when do lines run into each other? They run into each other at negative 2, negative 5. And that's the answer that we claimed this was going to be at. You might say again, Mr. Ko, it's easier if I graph. But that's because Desmos is doing the graphing for us. What if I had to graph this myself? If I had to graph this using all my skills, let's go ahead and graph this a couple different ways. We can graph this by changing this to slope-intercept form. 4x minus 4y equals to 12. Let's go ahead and solve for a slope-intercept form. Minus 4x to both sides. Negative 4y is equal to negative 4x plus 12. Let's get rid of the negative 4 by dividing both sides by negative 4. That's a 12, I'm sorry. That becomes y is equal to x. Let's see, that's going to be a minus 3. 12 divided by 4 is 3, negative 3. And then if I graphed it, again, look at my terrible / wonderful graph. Nope, quite terrible. Negative 1, 2, 3. Put a dot. Slope is rise 1, run 1. Okay, so we have some type of line here. And the next graph we said was y is equal to negative 5. Negative 1, 2, 3, 4, 5. Here's negative 5. And my second line. Here we go. Now, what point would that be? It'd be kind of hard. I mean, we're just kind of guessing, aren't we? Does that look like negative 1? What was our answer? Negative 2? Whoops. Negative 2? See how I fudged that a little bit? But see, negative 2 comma negative 5 is not as clean, it's not as obvious to see. And I had to do a lot of manipulation to get that first graph. Okay, so I would have to consider this, that when I have to graph something, yeah, it does work, but it's not the prettiest, and it's not always easy to find out what the answer is. Because there's no Desmos to nicely tell me, hey, where do they meet? Now, on the test, when I ask you guys to solve by substitution, I need to see the work. If I don't see the work, I think you're using some type of calculator or something, okay? And it's important that you guys know how to do the substitution method. Okay, let's go ahead and look at another problem here. Okay, let's do a quick one again. Actually, no, let's move on. Skip it a little harder. So here's my next equation. We have y is equal to negative 6x plus 10, and y is equal to negative 5x plus 7. As you can probably notice, what type of shapes are these? Y equals to negative 6x plus 10, and y is equal to negative 5x plus 7. Are these circles? Are these triangles? They're back to lines, right? If it's just simple x, these are just simple lines, okay? And then I could go ahead and try graphing them, but we talked about before, graphing isn't the most accurate way. I mean, do you really want to graph plus 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the slope is negative 6. 1, 2, 3, 4, 5, 6 over 1. Something like that. Oh, it's probably even worse. Okay, that's one line. The second line is 7. Please don't graph it. You guys don't have to graph it. 1, 2, 3, 4, 5, 6, 7. Something like 7. And then negative 5 over... Oh my goodness. So, something like that. Now, I have no clue where that point is. I don't. Okay. And my tick marks are quite terrible. So, let's use algebra and substitution to solve this problem. And again, this will take us about 2 minutes. Okay, now, how do we use substitution? We have to replace one variable for another variable. And if you look here, these are both equal to what simple letter? They're both equal to the letter y. Don't they both say y equals to? And in the system, the y's have to be equal to each other. They have to be at the same spot for them, for this system to be solved, right? This is the only point where they have the same x and the same y. So here's what my saying is. If y is equal to y, right? Because they have to have the same y. Well, the top y, negative 6x plus 10, has to equal to the bottom y. So we're substituting y for y. Another way of looking at this is I'm substituting this y into this y equation, right? I'm saying, hey, isn't y 6x plus 10? So I will write 6x plus 10 there. That's what we did. We wrote 6x plus 10 here. So instead of writing the letter y, we wrote 6x plus 10. All right, so given this, let's go ahead and solve this now. We want to combine our x's. Now, to reemphasize this, we start off with 2 equations and 2 variables, and we ended up with only one fat equation. Oh, I shouldn't write the word fat, but one big equation, and then one variable. All right, so let's go ahead and move stuff around. Which side has more x's? Would you say the negative 6 has more or the negative 5? Which one would be richer? Are you richer if you owe more or you owe less in this case? You're richer if you owe less. So we're going to add 6 to both sides. And you notice when I add the bigger number, this x is now positive, which makes my life a lot easier. I'm going to minus the 7 to both sides. X is equal to 10 minus 7 is positive 3. Okay, take a moment to reflect on that to make sure we're good. We said 6x minus 5 is 1x, and then we said to clean up on the x side, so I had to get rid of the 7, not the 10. 10's already on the other side. I kicked him out. He's out of the house. I need to get rid of 7. So opposite of plus 7 is minus 7. So I'm getting x is 3. All right, so the idea is that this is the same x that works for both equations. This is the common point that they're going to share. I guess if you look at my graph here, look, it does kind of look like 3, doesn't it? Kind of guessing there. Okay, now we have to find the y value. So you get to choose the first equation or the second equation. Is really up to you. Whichever equation you think is easier, because remember, they're both going to have the same y now. I'm going to go ahead and double check them both. But here we go. Y is equal to negative 6 times 3 plus 10. Right? So we used substitution. We substituted x equals to 3. That's what we came up with. Y is equal to negative 18 plus 10. And then y is equal to negative 8. Okay, let's see if it's the same answer if I use the other one. Y is equal to negative 5 times x, where x we said was 3, didn't we? Plus 7. And y is equal to negative 15. Oops, that's 15. 15 plus 7. 15 plus 7 is going to be negative 8. Oh my gosh, my graph is so terribly bad, right? That's totally wrong. My graph is terrible. So our answer is, we double checked it also, is that y is going to be equal to 8. So our solution for the system is 3 comma negative 8. Now I'm going to just again double check that using Desmos here, since we do have our workout shown out. Y equals to negative 6x plus 10. Okay, that kind of looks like my line. And y equals to negative 5x plus 7. So if you look at these two lines, they're, neck and neck with each other. We started one off at 10. We started one off at 7. And where do they meet? They don't meet all the way till, let me change this to projector mode. Oh, it is in projector mode already. They don't meet till 3, negative 8. Okay. So this actually would have been really hard to see if I had to graph this using a simple pen and paper. Okay. So when we have y is equal to equations, substitution is actually pretty darn easy. We can just plug one into the other, set them equal to each other, and then solve it, like we did in our first month of class. Now, let's go ahead and look at a problem in which it is not as easy, okay? So you'll end up with these next level problems. And let's go ahead and look at this next level problem. We have negative 6x minus 4y equals to negative 4. And 2x plus y is equal to 4. Now, this case, it's not y is equal to y is equal to. We don't have this nice setup anymore. We have to ourselves pick a variable to solve for, to substitute. We're going to have to pick a sacrifice. Now, if you look at the 6x and the 4y, they look a little crowded, don't they? 6x and 4y. So for me to solve for x and y there, it might be a little difficult. But look at the second equation. I see 2x and a y. Look at that y. Isn't that y by itself? And you could make this into a y equals equation, because we're going to use it to substitute. Now, the goal again is to solve for a variable. In this case, I see the y. This is my golden child here. This is my ticket out of here. So let's go ahead and solve for y. Minus 2x to both sides. Y is equal to negative 2x plus 4. Great, no fractions. Makes my life a little bit easier. But I would like to emphasize now, what is y in this problem equal to? Negative 2x plus 4. Y is equal to? Negative 2x plus 4. Y is equal to? Negative 2x plus 4. Because we're going to write this y here. This y is going to be substituted with negative 2x plus 4. Now, why do we have to do this? The first problem is that when you're solving for in algebra, you can't solve when there's too many variables around. Okay. Imagine if you're hanging out with friends and everyone's talking to you at the same time, saying different things. There's too many variables going on. People are saying too many different things. So what do? Right? What do teachers do? Okay, you can't do this as friends, but you tell your friends to stop, and then you point at a friend. Okay, you first, or you first, or you first. You don't tell them all keep talking at the same time. Teachers do this by raising your hand. I can't have all you guys yell at me at the same time. We have you guys raise your hands. So I'm going to have, in this case, y raise his hand, and then we can plug in y. So though no longer we're dealing with two variables, we're only dealing with one variable. So here we go. We're going to go ahead and plug in the y. We have negative 6x let's rewrite this. So we start off with two variables, two equations, and we said, no, that's too much stuff. Too much stuff is going on. But we're going to squeeze these together, and we're going to make a nice smoothie here of one equation, and y, we said, is going to be negative 2x plus 4. So y now is negative 2x plus 4. So please take a look. We don't write y anymore because we swapped it out. We traded it. You go to Chuck E. Cheese, you trade your tickets in for a toy, right? We traded our y for negative 2x plus 4 because that's more useful to me. Now we have to do our algebraic process now. We have to get rid of that parentheses so that we can solve this equation. So the way we do this, it's not 4 plus, it's 4 times. And we're going to multiply everyone inside the parentheses by our negative 4. Here we go. We have negative 6x, which hasn't done anything. And when we end up with negative 4 times negative 2 is a positive 8x. And negative 4 times positive 4 is a negative 16. And this is equal to negative 4. Now we can combine the x's together. I see negative 6x and 8x. We can combine these. What is negative 6 plus 8? That is a positive 2x minus 16 equals negative 4, right? We combine the 6x and 8. That's the part that's neat. My next step is now, hey, this is level 1 problems now. We got to solve for x. Let's get rid of the 2 of the 16. Which is farthest away? I'm going to get rid of the 16 to both sides. Add 16 to both sides. Opposite minus is plus 16. We end up with 2x is equal to positive 12. And then we can divide both sides by 2. X is equal to 6. Man, that seemed like a lot of work. Only if you're complaining. If you just do it, if you get the pattern, get the idea. That's the thing about breaking that math barrier. Understanding the pattern, understanding the steps, understand what to do, right? You know it. Now, am I done yet? I solved for x, but have I solved for y yet? And the answer is no. And that's where this equation comes in handy. See how this is y is equal to? This is already solved for. So we're going to use, whoops, darn it. Come back. We're going to use this equation here and plug in our x value. We're going to substitute x in to solve for y. Here we go. Y is equal to negative 2x plus 4. Y is equal to negative 2x plus 4. Y is equal to negative 12 plus 4. Y is equal to negative 8. All right, so we did a lot of cowboy math here, right? We did a lot of work. Now the question is, how do I double check this? Well, remember we had two equations here? We used the second equation to solve for y, but let's use the first equation to double check if we did all the work now. Now you can double check this so you can make sure you get 100%. Is we are going to use the original equation, negative 6x minus, is it minus? Yep, minus 4 y is equal to negative 4. And since we do have x and y, let's go ahead and substitute to just verify that this is the right answer. Here we go. Negative 6x, what was my x value? Minus 4y, what is my y value? And are we going to end up with negative 4 at the end? Let's go ahead and check. X we said was positive 6. Y we said was negative 8. Let's do the math. 6 times 6 is 36, negative 36. 4 times 8 is 32. That's going to be a positive 32. And maybe you guys are seeing this already. Does negative 36 negative 36 plus 32 become negative 4? Is that true? It is. Negative 4 is equal to negative 4. Yes, it is. Okay, as you guys finish copying that, I'm going to go ahead and graph these lines now because we have Desmos here, just because we're fortunate to have such a thing. I'm going to go ahead and graph these to see Was this the right answer? Did we do the right thing? I get it. We double checked it. It seemed like it was supposed to work. But just to graph it again, negative 6x minus 4y equals to negative 4. And 2x plus y equals to 4. And let's take a look where they meet. They meet at 6, negative 8. And that's our answer. We said our answer was 6, negative 8. Let's go to re-actualize that. Our solution is 6, negative 8, where this is x and y. And that's our answer that we got also in the graph. Okay, so that's what you guys are going to do in Excel today. You guys are going to solve for a variable. If the variable isn't solved for you already, and then you're going to plug that in. I'm going to do one more problem just so you guys have this on record. Okay, one more problem so you have this on record. So this problem looks like this. 8x plus 6y equals to 16, and x minus 2y is equal to 12. Okay, x minus 2y is equal to 12. So look at the next problem. Which variable here do you think we could use as our substitute variable? Which variable here does it look like it's pretty much alone? It's pretty much good to go. Would that be x or y? Would that be x or y? And part of math is knowing where to start, right? Knowing where to start. Hopefully you guys have realized that it's going to be x here. See, x is not almost alone. So I'm going to actually work with that equation. I'm going to plus 2y to both sides. And we're going to say x is equal to, that's a y, sorry. X is equal to 2y plus 12. All right, we have our substitute variable. X is equal to 2y plus 12. X is equal to 2y plus 12. X is equal to 2y plus 12. And we're going to plug that, substitute that in to our first equation, because that's the ugly one. 2y plus 12. X is now 2y plus 12, everybody. Plus 6y equals 16. Again, this is really just the algebra behind it. We're working on our algebra. Now, this is literally what we've been doing since September. We distribute the 8, that's 16y plus 8 times 10 is 80, 8 times 2 is 16, 80 plus 16, 80 plus 16 is 96, right? Plus 6y is equal to 16. Hey, we have y's. I see y's here, like terms. So I'm going to add our 6y. I'm going to add the 16y and our 6y together. 16 plus 6 is a fat number. 22y plus 96 equals to 16. Right, that's 22, right? 16, 6, yeah. Okay, let's go ahead and subtract some values here. I'm going to get rid of the 96. We have 22y is equal to, if I subtract that, it's going to be negative, I want to say negative 80. Uh-oh. Oh my gosh, I miscopied the problem. Oh my goodness. Such trash, Mr. Co. I miscopied the problem. Oh my goodness, folks. I'm going to go change some stuff, please. I miscopied the problem. This is supposed to be a plus. Oh my gosh. If that's a plus, that means this is a minus. That means this is a minus. I was wondering why my answer wasn't coming out. It was actually, that's a minus, okay? Sorry. If this is a minus, this is a negative. 8 times 2 is negative 16 here. And I'm going to change this right here. 22 is no longer 22. It's going to be negative 10. Oh my gosh, Mr. Co. Why are you doing this to us? And this here would be also negative 10. So if you take a look at the reds, that's the places where I messed up. Oh my goodness, I copied it wrong. Should double check. How many guys have done that mistake? No, Mr. Co, it's just u. Then we divide both sides by negative 10, and that makes more sense. Y is equal to 8. Oh gosh, it's like writing in a crayon. Y is equal to negative is a positive, 80 divided by 10 is 8. Okay, so now that we solve for our y's, y is 8, we have to go back and solve for x's. So x is equal to, look here, x is equal to, we have a nice x equation. I'm solving for x. X is equal to negative 2 times 8 plus 12, because we substituted y is equal to 8 into the problem. X equals to negative 2 times 8 is 16 plus 12. X is equal to negative 4. So our solution here is negative 4 and 8. To double check the solution to make sure this is true, let's go ahead and plug it into our first equation, our ugly one, 8x plus 6y equals 16. 8x plus, is a plus, 6y equals to, I'm going to actually not write y there, 6y equals to 16, okay? Now what variables we're plugging in? We're going to plug in x and y, plug in x and plug in y, negative 4 and 8. And if this is true, we have a solution, and we verified it, negative 32 plus a 48, does that equal 16? And yes, it does. So this is the correct solution. So just to recap, what are we doing today? Today we are working to solve a system of equations, not by graphing, and we did verify our solution. We did support what we did do by graphing it, yes. But also, we have a new method called substitution, where we take one variable and we plug it into the other equation, mixing both equations into one and solving for that one variable. We start off with two equations here. We solve for, we start with two equations. We solve for one variable so that we could plug it in, and then we're able to solve for the one variable first, going back and solving for the second variable.